Okay, hi, I'm Scott, and I'm a live coder. Just wanted to say, first of all, thank you to the organizers. I think this has been a fantastic few days, and they've done a really great job, and it's wonderful to see this keep going. So thank you for making this happen and for letting me be here. As Konstantinos said, in terms of my live coding related background, yeah, mostly Super Collider. I've been involved in Super Collider development for probably 20 odd years or something now. It's probably fair to say that I've created some problems as well as some solutions. I was also involved in a laptop ensemble in Birmingham, which was called the Birmingham Ensemble for Electroacoustic Research, which, turns out spells beer. Who knew? We're very fond of sort of silly acronyms in Birmingham. We're sort of not sure where it's going now, but it ran for 10 years anyway, and its sort of focus was networked systems that incorporated live coding, and this kind of idea of pieces that were a structured network system that somehow imposed some sort of structure or form or procedure onto what we were doing with the live coding. So I guess that's, if I have a kind of unique contribution to this, that's maybe what it was, along with people like Konstantinos and the other members of that group. I'm also involved with Beast, Birmingham Electroacoustic Sound Theatre, which is a giant kind of like 100 loudspeaker system for immersive audio. Not super relevant to the live coding thing, but I just thought I'd mention it. I'll maybe say a little bit about that later. We're 20 years into TOPLAP now. The founders, like me, look sort of increasingly exhausted and grizzled, and so I thought, as it's been 20 years, this might be a nice occasion to sort of pause, undertake a little bit of reflection about live coding, where we are with it, what's happened with it, and maybe also sort of how it might fit into larger contexts, how it might interact with other things in a kind of broader musical ecosystem, if you like. I should say at the outset that I'm a composer, a musician, and a sound artist. I'm not really a computer scientist or a historian of computing, so I'm coming at it from that angle, this topic, and also with the kind of limitations you would expect from that. So if I say anything particularly dumb, that's my excuse for what it's worth. And in going through this, I'm going to look at some examples in music, which will be actually from my own work. But I think we could also apply this to visuals, for example, and I think we could all think, even from these few days, of some other examples of the way live coding has kind of interacted with other things. So here's the thing, basically. So what is live coding really? So I'm going to try at the beginning here to sort of answer that in a way from a particular angle. And I'm going to propose that we think of this in sort of terms of computer science paradigms. So when we get to sort of the end of the talk, we'll try to think about live coding sort of in imperative terms, if you like. So that would be more sort of thinking about how do we do things. But before we do that, I want to talk more about in a kind of declarative way. So in terms of what. But also, we're going to try to look at it exploratively, which is another kind of computer science paradigm, right? Like explorative programming. And this is the kind of programming where you define the problem in the problem space through the act of solving the problem. So in a sense, you could think of that as we're figuring out what through the process of figuring out how. And that's kind of really important. So just sort of maybe stick a pin in that in your mind, I think, because it's quite relevant, I think, to the topic. And so we're going to go through and we're going to look at what live coding might be, what it seems to not be, and how it might differ from things that it's not or is mostly kind of not. Right. So if we imagine that I'm a kind of mediocre student, perhaps not too big a stretch of the imagination, the first thing I'm going to do, of course, if I want to know about live coding is go to Wikipedia. And I notice, immediately, because I'm easily distracted, that, there's this thing right at the top of live coding that says, not to be confused with interactive programming. So I'm easily distracted, so of course, what am I going to do? I'm going to click on the link for interactive programming, see what that says. And it says, oh, not to be confused with live coding. Now, this is a kind of anniversary year. So in the spirit, I think, of questioning all the shibboleths, great and small, I think it's a healthy thing to do. I'm just going to say at the outset that what I would like to do in this talk is very much confuse those things, despite the directions that we've been given there. And I think, this is fair, because if we sort of dig into this a little bit and see what it says, it is a bit confused, to be honest. So on the live coding page, it says that live coding is most prominent as a performing arts form and a creativity technique centered upon the writing of source code and the use of interactive programming in an improvised way. So, from the outset, it sort of was trying to say that these things are not the same, but in fact, it seems like maybe live coding is just a special case of interactive programming. So is the problem here the notion that maybe interactive programming isn't improvised, which I think would be a kind of funny way of thinking about it? Or is it just the context where live coding happens? So it has to happen in performance, perhaps. Or if I wanted to be really cheeky, I could ask, is live coding just a sort of a brand, in maybe the sense that algoraves is a sort of brand? I hope nobody takes any offense at that, but I think that's fair, right? There's algoraves, it's a website, it's all over the world, it's a concept. So maybe live coding's like that too. It's a kind of a thing that we put out there as a brand to sell it, in a sense, or propagate it, or promote it. But for the sake of this talk, I would say that context, this idea of it being in performance or somehow performative, is not necessarily what's the most interesting or important in terms of what I'm going to talk about. It's other things. So for example, if I can use the maybe slightly past fashionable term, the affordances of live coding. What does live coding offer us? And as we sort of go through this, I think it's also really important to sort of ask the other question, which is, what doesn't it offer us? That's probably just as important. So probably the most obvious one that comes up in the first instance is this notion of flexibility, right? So this idea that you can do a lot of different things in a kind of exploratory way going through. And I'll discuss this one by way of an example from my own work, just talking about how I kind of got into live coding. So my first uses of live coding were from before I really knew what it was. Oh, that's interesting. The video's not playing. Let's see what's happening there. Gonna play? Try again. There we go. So I had this kind of extended piece called Musik. It was using kind of recycled musical material. For the live performances of this, I'd written a kind of bespoke granulator class. This is going back to around 2000, somewhere around there. And I wanted to incorporate that into my live version of this. And I tried, various sort of GUIs and things, but I realized very quickly that the simplest thing to do was just to have it pop open a small code window and just pre-populate this, if you like, with some sort of boilerplate code that's configured to granulate whatever file I'd selected. Now, I was doing this without any kind of idealist or ideological idea about live coding and doing that. I wasn't really thinking about that. I was just interested in finding a flexible way to do what I wanted. But that said, once I started working that way, I was hooked. Because I realized that this approach could open up possibilities that I just hadn't anticipated in advance. It let me do things that I hadn't thought in my head that I might want to do. And that seemed to me kind of almost impossible to do in any other way, with the GUI or something that was pre-configured, because that kind of bakes in certain things in a way that live coding isn't baked in. And on the back of that, I started in my work with Beast, sort of coming in when we set up the system. It's quite a big thing to set up 100 loudspeakers, and I was working long days, and kind of my reward for that is I'd sneak in on the Sunday morning and I'd sit down on the system computer and just live code spatialization algorithms over these speakers. And that kind of started feeding into my approach to spatialization and stuff. So by this point, I'm really addicted to this idea that I can just kind of flexibly find my way through different things that I want to do without having had to plan it in advance. So that's sort of the first one, as I said. So the second affordance that maybe people like to talk about is this idea of immediacy. So we can decide to do something and we can do it very quickly. And I think in broader terms, computer science programming has really become quite besotted with this notion over the last couple of decades at least. And we've seen this kind of massive growth of interpreted scripting environments. And this kind of nice idea we have, we're working on our JavaScript, we can just reload the browser and see the changes to our JavaScript. And I think, that it's interesting that a lot of live coding environments have gone in quite heavily for this. So browser implementations, for example, somebody else was mentioning this the other day, really give you this kind of ease and ubiquity. You can run it maybe almost anywhere, and there's no kind of setup BS. You just kind of load the web page and it runs, right? So that's really nice. And, if you think about it, I think you have to realize, admit there is a kind of undeniable appeal to this sort of way of working. And I think there's some of us in the room who've done C or C++ development, and who's done that has not experienced the kind of frustration of this kind of code compile run cycle that we have to deal with in that. Which requires a huge amount of infrastructure to support. You've got to get your tool chain in place. You've got to get everything all kind of set up. And weirdly enough, as time goes on, this just seems to get worse. Anybody who's tried to, set up a build environment on an Apple machine and deal with all the code signing and stuff, that's terrible. And so all of these barriers are kind of, in the way of just, what you might want to do, which is, just try something, to see if it works. And I think, you can see this, that this is appealing through the availability of things now like Ceiling, which is, bills itself as an interactive C++ interpreter, or, the various online C compilers. You can see one here. Why is that not playing? Come on. Nope. This is really funny. Come on. So there's one there. So here's an online C compiler. And you can just go there, type in some C code, and see if it does what you think it does without having to compile the program, set up a build chain, run it. Obviously very, very, very appealing. And yeah, it works, right? Well, my video doesn't work, but that's another story. Okay, so the next one is maybe a little bit less obvious, but this idea of preferences. So live coding languages, for whatever reasons, it seems to me, seem to offer, or at least allow us, this possibility of tweaking what we're doing to do it in our kind of own individual way. I think, partly this comes from the fact that you're often thinking about speed, shortcuts. People are implementing all of these systems, perhaps on top of another environment like SuperCollider, if you're dealing with something, or Python, if you're talking about Foxdot or something like that. So we're trying to think, how can we actually code because we want to code fast? So that leads us to this kind of idea of optimizing to our preferences. And so if we sort of step back from that for a minute and think about things in a little bit more theoretical way, computer science, and again, forgive me, computer scientists who are in the room here, but it offers us this notion of a language or a machine or environment being Turing complete. So in sort of very simplified terms, we could say that any Turing complete language can implement any algorithm, and thus all Turing complete languages are Turing equivalent. In some senses, this is like an interesting question, right? So we can do the same things in SuperCollider that we could do in Tidal. We could do the same things in Max or something like this, right? We could probably do the same things that we do in SuperCollider in C. So far, so good. But whenever I think about this, I'm reminded of the famous computer scientist Alan Perlis, and he wrote this set of epigrams, which are really lovely. My favorite one is this one that says, "Beware of the Turing tar pit. in which everything is possible, but nothing is easy. And so this is a kind of nice idea, right? Like, so you've got an environment, it can do whatever you want, but, maybe everything's hard. So I think a good audio example of like a Turing tar pit would be like going into your audio editor and writing every sample one at a time. Yeah? I mean, like, you could do it that way, right? There's nothing that you couldn't do in that you could do in Super Collider, right, in terms of audio output. But it's not a great way to do it. So the question then is, once we kind of climb out of the Turing tar pit, this is going to involve making choices. It's going to involve making assumptions about what we want to do, and it's going to involve making choices about what we would like to make easy. And we also, when we do that, we have to kind of accept that some things are going to become awkward because of those choices we made. There's consequences, right, to like choosing to make something easy, to making assumptions about what your users are going to want to do. And I think the kind of crucial thing there is this sort of interesting tension between, what's prepared and what's unprepared. And I think that's a really useful way of looking at live coding or interactive programming. So in a sense, the question here is, whose shoulders are we standing on? And, this could include standing on our own shoulders, work that we've done before, libraries that we've done, preparation that we've done, despite the kind of blank screen idea that was, pushed a lot in the early days of the live coding communities. I think most people probably don't start with blank screens these days. I think that's fair. But in any case, something is always prepared, right? Even if it's just the environment we're working on. So if you're working in Tidal or Super Collider, you're basically basing what you're doing on thousands of hours of work by other people that have come before. So how do those assumptions about what you might want to do, about what you might want to make easy, make other things difficult or even almost impossible? And maybe we've come up against this sort of thing where you realize like, wow, Tidal or Super Collider or JITlib and Super Collider or whatever environment you're working in just isn't quite set up to do this particular task well. Yeah, I think so. And so when you think about that idea of choice, I think it's kind of interesting to kind of consider that in the context of this proliferation that we've seen of live coding environments. So if you go to the TOPLAP website, you can find a page that's just a huge big list of languages, right? Some of them are defunct, but nevertheless involved, presumably many hours of work that somebody devoted to make this kind of live coding tool that they wanted. Here's a bunch of them, by no means an exhaustive list. But in many cases, so why did people do this? Why make another live coding environment? There's already so many. And in many cases, I think this sort of seems to be because somebody wanted to support their idiosyncratic user style or preference, or there was something about one of the existing ones that bugged them or just wasn't quite optimal or something. So we'll do another one. And as I said, here's a bunch of the ones that are listed on the TOPLAP website. And you'll notice actually that some of these are not even really what we would consider live coding languages in the normal sense. So something like regex is quite interesting. It's actually a VCV rack plugin that lets you do kind of mini live coding in a funny way. Or Faust Live, for example, was listed there. I was kind of surprised to see that one, because I would think of Faust Live not so much as a live coding environment, but more as a kind of rapid prototyping environment for DSP and synthesis. And then also, Sema is, I think, really interesting in this kind of context because it even lets you make your own mini live coding languages. So it's sort of meta in that sense, which is cool and sort of virtuosically nerdy, right? Like I think that's quite cool. And if we sort of take this to an extreme, we get to a kind of, esotericism. Like some of these things are really strange. But I think, again, maybe the reason that there are so many of these different environments is that there's a sort of simple joy that you can find in just solving a problem in your own way, right? And I think we've all, if we're coders, we've probably experienced this. You know, coders are nerds. I think it's fair to say, anybody wants to object to me calling them a nerd, you know, go ahead. But I think we're nerds, and nerds love a problem, right? Nerds love a problem. So live coding allows us to innovate highly personal, idiosyncratic ways of solving our problems, you know, sometimes on the fly. Sitting here again at the kind of juncture of 20 years, I think it's really a joy to see the kind of evolution of expressions in something like Tidal or the practices of PowerBooks Unplugged, or, you know, from my own experiences doing 10 years with beer. And if you go to like environments like Orca, you can get even more extreme examples with very strange syntax or interfaces and things like this. Whether or not these are all used or not, I think there's something really lovely about the fact that these have proliferated in that way. And this gets even more complicated, these kind of questions, when we start to think about the possibility of combining live coding with other things in some sort of way. So in thinking about this, I've kind of come up with this notion of embeddable versus imbuable. I couldn't quite come up with a good word for this, but so the idea is something that you can embed into something else versus something that you can embed something into. Maybe somebody has a better word for that. But we can sort of think about live coding as a sort of matryoshka doll that can be put into other things and have other things put into it. And as a kind of simple example, you might consider an object or even just a bit of code or something that is in your live coding environment that, say, plays a MIDI file. So you've now embedded this whole piece of music into your live coding environment. Or an object that, say, does some machine learning analysis, which you can then use in your live coding, or you can live code the analysis, all these kinds of things. And yeah, so interactive programming can be embedded in other environments. So for example, from my piece above, where I just, it wasn't really a live coding piece, but I popped up little bits of live coding here and there when I felt like it was useful. Or we could imagine here that we've got some, machine learning embedded into your live coding environment, which is embedded into a broader kind of framework which you've made, which might include hardware controllers or all sorts of stuff, right? And I think you can also think more broadly of the way that scriptability and interpreted scripting environments have been embedded in sort of all sorts of different environments, including, software that we don't think of as coding environments per se. So for example, like a lot of DAWs actually have a scripting environment, or something like Blender is like super, almost frighteningly scriptable. So this is maybe a good moment to think about some examples. We've arrived at the title in a way. Live coding is part of a wider ecosystem. So as I said, I'm going to just play a few things from my own work. It's the last day in the morning, and I think it's probably nice to hear a little bit of music now. But yeah, as I said, I think we could find lots of other ones, and we've heard a few. For instance, Ivan and Shelley's work with machine learning that was mentioned yesterday. And I think in all of these examples, this question of what these affordances are and what they offer us and don't offer us still apply, even if the way the live coding is used in these examples is not for a performance per se. So it's kind of the affordances that make live coding or interactive programming, maybe useful and interesting here. So the first piece that we're going to talk about is called piano code. And this was a project that we did with beer and a pianist friend of mine, Xenia Pestova, who's a wonderful pianist who's based in the UK. And we wanted to do something with her. And so we immediately were just thinking, like, well, how do we kind of bring a pianist into the live coding world? And the obvious thing to do, it seemed to us, was to sort of do some machine listening that would try in some way to transcribe, or perhaps poorly transcribe, because maybe that's interesting too, what she was playing. And I think we all know about, the issues that still exist with things like polyphonic pitch transcription in real time and all this kind of stuff. But that's what we were doing. So basically, we had this thing that would produce some data, and then we could live code that data. And what we discovered very, very, very quickly was that she just didn't work the way we did. She was thinking a lot about now. We were coding slowly. And so she could just produce masses and masses of data faster than we could do anything with it. And more importantly, in such a way that by the time we did something with it, like quite a lot of time, 30 seconds or a minute might have gone on, which in musical time feels like quite a long time to do something that's somehow related to something, right? So we kind of came up with this sort of a novel interface to deal with that. And if you sort of see in the top left there, there's something that's a little bit like a piano roll. And you're basically seeing the last, 10 seconds or something of what the computer thinks somebody's played. And what you can do is you can kind of grab that very quickly by dragging across it, and that'll pop up a code window that's been kind of populated with, again, some kind of boilerplate code that you can live code with and quickly play. You can start it playing immediately, you can loop it, you can modify it. You can create your own kind of extensions in the system, actually, even while you're playing, to do different things if you want. And that seemed to work really well. And in as much as this is a piece, and one of the funny things with beer was that, we had this idea of structures or techniques or frameworks that were imposed on something. That was sort of our idea of what a piece was. So in as much as it was a piece, this might have been one of our most successful ones. And so you can see here, it's piano code, but it's also bass code. We did a version with 2 bass players. Dirk code, I did a version of this with my friend Dirk Stromberg, who's an instrument builder based in Singapore, who makes electronic instruments. And Konstantinos was doing a version of this recently with traditional Chinese instruments. So it kind of gets around. I've got a little demo here. I hope the video actually plays this time. I apologize for the quality of this. I've just done this in my hotel room, and the transcription is not very accurate, but you can see how that's perhaps useful. So it's me whistling, which is... you can see why I didn't go in for a career as a professional whistler, but let's see what happens. Yay! Grab it, it pops up. Let's kind of change what it's doing with pitches. You can copy that, make another version. Octave. Of course, this is actually, because I'm doing it in the hotel room, it's hearing what it's playing and actually transcribing that. But that means I can do something with that. Different sound, maybe. I think that worked really well in the way that it kind of overcame the limitations of the system. And that, for me, really got me thinking about live coding, what it's good for, what it's not good for, where it's really helpful for me to use it, where it's not, right? And I feel like this is, if you look again at some of the things that are going on this weekend, that feels to me like a sort of place where we are. People are kind of, AI is a big thing, obviously, these days, building stuff in. So another example, this is very recent, so I just like talking about it, but this was a piece for string quartet and electronics I did, which is called On the Memory of Trees. And basically, I was involved in a thing called the Memory Project, which was 6 pieces for string quartet and electronics, 3 Columbia-based composers, 3 UK-based composers, and all on the theme of memory. And if you know anything about Columbia, when you start talking about memory in Columbia, you get into some pretty heavy, serious stuff because there's a lot to remember there. And I was thinking, what am I going to do as a kind of Canadian who's ended up living in Britain? And as it happened, somebody sort of showed up on my doorstep saying, hey, do you know how to do sonification? I was like, well, actually, yes. And this turned out to be somebody from this thing called the Membra Project at the University of Birmingham. And this was basically exploring this idea of the epigenetic memory of trees. And so basically the idea in short is that trees can be exposed to stresses, so something like higher temperature, drought, more carbon dioxide in the atmosphere. So a lot of this is related to climate change, as you see. And the idea is that this will alter the epigenetic markers on the tree's genome, more methylations if you're interested in it more technically, and that it can then remember the adaptations that it's came up with to deal with those things if they happen again, and more importantly, pass those adaptations through these epigenetic markers onto their descendants. So this idea of memory being in trees. So I basically got their data. I wanted the whole piece to be based around sonifications of the data that they'd given me. And I used live coding here in a sort of series of rapid prototyping sessions. So I'm just going through, trying to come up with things that work. Once I got that all together, I took it, I made electronic sounds, I put it into Sibelius, I distributed it in a way that worked for a string quartet, because obviously they're not necessarily going to be able to just do whatever I ask them to. But ultimately we end up with a fixed piece. And I'll just play you a little bit of that. This is the absolutely wonderful Ligeti Quartet, who are, in addition to being a fantastic string quartet, are just fantastic human beings. So I mean, again, this is a fixed piece of music in the end, but I think for me, it would have been really hard to do this without live coding. That kind of way of just getting data. Of course, if any of you have done sonification before, you hear these things in the news. Oh, this is the sound of climate change, right? It's terrifying. We've heard somebody turned climate change into sound, and it was terrifying. It's like, no, it's not terrifying. The output of the algorithm, the mapping that somebody made it sounds terrifying. But finding good mappings that work is actually, quite a lot of work. And live coding is a kind of nimble way of exploring that. Being able to kind of go through, find things that worked, modify them while they were running was just super useful for that. The next one is a little bit similar, which actually came before, but I'm talking about it second because it's more elaborate in a way. So Konstantinos, who's here, Vasilakos, started this project with some people at CERN to sonify data from the Large Hadron Collider. And there's a project there called ART at CMS. So CMS is one of the two big experiments on the LHC. And basically both of those, the other one's called ATLAS, they're basically trying to find new physics. They're looking for new kinds of forms of matter that explain dark matter, the stuff that they know from the way the universe behaves exists, but they can't explain what it is. So basically we were getting there, a lot of people who were involved in that project were doing things like paintings that were kind of inspired by physics, but we really wanted to work with their data, which I think really the physicists were quite pleased with. And so we came up with a kind of novel interface for this. So you get basically like a list of like 1,000 events, they call them, and each event is a particle collision where you've got a sort of snapshot of what it looked like an instant after the two protons collided. And you've got all the subatomic particles, and you sort of know where they are, how far they've moved out from the collision point, which is basically the same as their velocity, and maybe some information about their mass. So we came up with a kind of GUI interface which would let you kind of select a different event to sonify. And we kind of, again with this idea of customization of preferences, we rolled into our pattern classes we developed in SuperCollider this idea of a active event. So basically what this meant was that you could set up a sonification of a particular event and then change the event it was sonifying while it was running. And this seemed to work really well. This was also kind of like built into a network system which let us see what each other were doing. It let us kind of share visualizations of the events that we were sonifying, code projection, and things like this. So I'll just play you a little bit of that. This is the premiere premiere, actually, which was in Birmingham Open Media. If you look very closely, you can just see a very young Konstantinos Vatsalakos there and a very young me as well, before the years of live coding of Stardust in the interim. But it was quite fun, and you can see a very early version of the visualizations we did. These were done by Winston Jung, who was also just not there. Spinning around is maybe closer to the shape of the collision, what you would get from the visualizations from CERN, marking out how far out from the center things are done. But the other ones with the flashing globes are more abstract. See some code projection floating around in there. But the main point is it's visualizing and it's showing you in some way what's being sonified. So this was quite a nice project in its own right. And we did this in many different places over a number of years. But I had the opportunity at some point to do a kind of a sort of a baby spin-off project from this, which was actually to do a piece related to this stuff for orchestra with multi-channel immersive sound and video, Now, I don't know if anybody's ever worked with an orchestra, but, it costs a lot, and if you do to get an orchestra piece done, you maybe get 2 rehearsals, so you probably can't really be live coding in that. But all of the work that we've done with the laptop ensemble, all the development, all of the different gigs and all the experience had kind of set me up with tools that I could use as a kind of laboratory for this. Again, kind of live coding sonifications, changing them while they're running, getting things that I liked. And I realized that, the visuals that you saw there were done in processing. But I realized I had the opportunity to do some better quality ones. So I'm not really a graphics person, but I thought, let's come up with a strategy. And so I decided to work with Blender. But I needed, because I was doing these live coded sonifications, some kind of way of documenting what the live coding output was so that I could make use of it in offline visualizations. So how'd that work? So basically, again, I kind of changed my preferences. I modified the live coding patterns to produce a kind of side effect, which was that they would sort of log a bunch of data. So as it was generating the sound, it would basically record in a text file what subatomic particles, what components of the event were being sonified, and at what time. And then basically I was able to kind of import that into Blender using a script to generate the elements of a scene, which I would then kind of tweak, again, basically live coding it in Blender, even though that's kind of a rendering environment, not really a live coding environment. I mean, Blender is actually really interesting for this, because I think it's actually like, from a kind of software safety perspective, it's sort of insane. I mean, you have access to everything in Blender. It's not just a kind of cute API that you can do a few things with. It's like you could completely take apart the interface and stuff. So that was very, very flexible. And then the nice thing is, so once that's not the usual way to generate something in Blender, to import in a Python script and, live code it out to look like something like that, or one of the other visualizations I used. But once you've done that, then you have access to all the stuff that Blender is actually good at. Camera angles and moving that and timelines and things like this. All the sort of heavy lifting stuff that probably would have been, a lot more work to do if I was kind of scripting it up from nothing. Yeah, and so then I generated these and they, synced them up with the sound files I'd created, and that worked really perfectly. I'll just play, I'm a little worried about time. Are we okay to sort of go to about 10 after or so? Yeah, okay. Something like that. I want to leave a little bit for questions, but I'll play a little bit of this and maybe jump around a little bit. So this is the Esprit Orchestra in Toronto with the conductor is Alex Pock. No, I can't. Oh well. let's just move on anyway. I think you get the sense of that. Okay, so we're sort of into the home stretch here now. And let's switch modes, think maybe a little bit imperatively, and consider a little bit more of the how of live coding. So what does that really mean? On a very basic level, I think it comes down to essentially text, or at least this sort of concept of code as an interface. So we're using code the way that we might use a GUI or a physical controller or something else. Code is your interface. And just caveat, I say text. I'm aware sometimes it's not text, and there are coding languages that don't use text. But often we're talking about text. And if we think, what does the word code even mean here? And I think, in a simple sense, something has been encoded. And we'll talk about what's been encoded in a moment. But before I say that, I just want to kind of, pause here, because I think this, code as interface is kind of live coding or interactive programming's sort of killer feature, right? But it's also, because it gives you that flexibility. It gives you that ability to do, to explore your preferences. But it's also live coding's killer limitation. So again, the route that we choose to take out of the tar pit has consequences, right? We're making some things easy, we're making other things hard. So again, code is the interface. And it says here, interactive programming focuses on the program text as the main interface for a running process. The activity of writing a program becomes part of the program itself. And so, importantly here, code as interface is not, or at least usually not, I would say, a metaphor for something physical. At least, not in the way that like a set of GUI sliders and knobs would be a metaphor for something physical. It's really rather more an encoded form of thought. It's a way of encoding a thought. It's a way of expressing or encoding an algorithm in a useful form such that it makes it applicable to the world. We can change the world by making sound or making visuals. Now, probably you're all here familiar, or mostly here familiar with the TOPLAP Manifesto, which, I note, perhaps with a kind of a note of celebration, still a draft after 20 years, and maybe it's very much in the keeping of live coding that it should be. But most people's favorite bit, probably mine anyway, is this one, which says, live coding is not about tools. Algorithms are thoughts. Chainsaws are tools. That's why algorithms are sometimes harder to notice than chainsaws. And this is, maybe one of the most iconic phrases about live coding, I would say, yeah? But again, in the spirit of sort of challenging the shibboleths, we could ask, what if a chainsaw was a form of thought? I'm joking. Maybe. But follow me through on this, because I think it tells us something interesting about the tension of code as interface and this kind of tension between the killer feature and the killer limitation. So an important affordance of code as an interface is that it's flexible and potentially very expressive. You can do almost anything, but slowly, not necessarily quickly. So in that sense, it's not really immediate, right? Like, it's maybe, if we imagine a kind of continuum, where on one hand we've got out-of-time composition, on the other hand we have completely in-the-moment improv. It's sort of somewhere in between there, probably usually more towards the improv side, but it's in the middle. And I think, we'd probably say more commonly live coding is sort of pacefully thoughtful and exploratory, probably more often than it's sort of like in the moment, now, right? And this leads us to, sort of one of the more unique properties of live coding improv, which is that we're often thinking ahead, right? Maybe a minute or even more ahead. And we're probably doing that as much or more often than we're thinking about now. And I think this has actually some fairly profound implications on the music. You're often forced, out of necessity, to develop new musical ideas over the sort of mid to long term, right? And this kind of leads to this, and we've all seen it a million times, we've seen it this weekend, this sort of standard practice in live coding. What do? We layer, right? We start a layer, we modify the layer, we maybe add another layer, we modify that, we remove some layers. That's the sort of normal kind of procedure, I think. Why? Because it's hard to start something. At least if you're doing it from scratch, it takes a while, right? And anybody who's ever done the blank screen thing, I think has experienced the discomfort of like everybody's waiting for me to finally make a sound, and then you make a sound and it's dunk, 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 like whatever, right? That kind of thing. So it's hard to start something, but it's easy to modify it. And again, this has formal implications. Live coding is very often evolutionary in its development, rather than kind of with a lot of hard changes and sharp changes. But you can get faster, yeah? I mean, it is possible if you practice to get to the point where expressing yourself in code can become more natural, more fluent, more fast. And I think anybody who's ever seen someone like Andrew Sorensen code knows this is true. It's almost terrifying, right? Like it almost feels like he's coding almost as fast as he's thinking. So we can get there. So I kind of have to ask if it's possible for the act of coding to become second nature to the point where you're sort of naturally, without thinking about the tool, it's just kind of part of you. If you're just naturally doing that and expressing your will with code, why not when you're expressing your will with a chainsaw? How is that really different? And it's basically Zuhanden, Vorhanden, right? Tools becoming a kind of unconscious extension of your mind. And apologies for the joke, but I would argue, as a lot of people do, that computational devices are in some sense an external extension of our brains. So if a running algorithm is an extension of my brain that allows me to affect the world, why isn't a running chainsaw? It certainly allows me to affect the world. Okay. I'm being a bit foolish and speculative here. Of course, chainsaws are not thoughts. And of course, algorithms are thoughts. Though given they're actualized as tools, I probably wouldn't go so hard on that distinction as the Manifesto does. But why am I even kind of dwelling on this sort of, pound shop philosophical speculation? Well, because it's good to be wrong. Being wrong lets us learn how to be right. Cool. To find a better way by doing. Being wrong, turned on its head, can become a new way or ways to be right that we'd never even previously thought of. I would say wrong is beautiful, at least potentially. So if I sort of go back now to the third category that I mentioned of exploratory programming, we can see that this kind of exploration is, I think, really the key here. It's the main affordance of live coding or interactive programming. And again, this is reflected in the musical output, as well as our visual experience, if screens are projected. And I really love about these kind of live coding performances, this nice counterpoint between what we see, watching this kind of thought process on the screen, and what we hear, because it's not the same, right? It has a different rhythm. And live coders change their mind. They retract. They go back. They stop. They find something better. That's, really a big part of it as a kind of way of making music. And as audience members, I think it's kind of interesting that actually, in ways that we wouldn't be if we went to hear the symphony or a rock concert or something, we're up for that, right? Like, we're quite happy with that. We don't mind that the performance is an exploration that has some dead ends, that, has some mistakes, that changes direction. And I'd go so far as to say it's like actually even part of our value system. In the sense that, you wouldn't say to same sense that you wouldn't say to a jazz musician, why don't you just write out your solo and practice it till you can play it perfectly, because then it would be perfect. Like, that's the wrong question, right? So asking a live coder, like, why don't you just plan totally what you're going to do so you don't make any mistakes, you don't do anything wrong? It's the wrong question. It shows a misunderstanding about what we value in that music. We can say a lot more about that, but I just, say, as a society, I think we underrate wrongness. There's too much emphasis on being right early and often. So I think a really great thing about the live coding community is that we somehow embrace that as a value. Right. So to repeat and sort of sum up, I think the incredibly useful aspect of exploratory programming then is that it allows us to determine not just the implementation of a solution, but the requirements and the specification of a problem through the act of programming. We understand the problem by solving it, not by knowing it in advance. And it just strikes me that this has a huge, huge, huge amount in common with artistic practice, right? When we set out to make a work of art, part of the problem of making a work of art is we don't know what the problem is, right? We've got to solve it as we go. So I think it's absolutely wonderful that there's this kind of programming paradigm that somehow just has that baked in at the ground level. I think it's part of what makes live coding really wonderful for art. And I think that's true whether you're doing it as an improv in a performance or using it in some other context. I think that's why it works for us so well. Because in addition to being nerds, we're also artists, right? And those things are not mutually exclusive. So Constantino said to me the other day, if live coding is the solution, what is the problem? And I think that maybe this kind of exploratory solution finding and all that you might get from being open to working in that way is at least one kind of possible answer to that question. So, as I've been given a sort of pulpit here with this keynote, maybe you'll forgive me if I'm just a little bit self-indulgent at the end here and just ever so slightly preach to you. And I'd just like to say, keep exploring, keep figuring out what the problem is by solving it, and keep being gloriously, determinedly, unrepentantly wrong. Thank you.